How does induction cooktop work? We know that heat can be transferred in three ways: by convection, thermal conduction, and radiation. An example of heat transferred through radiation is the heat from the sun. In case of radiation, there is no need of a medium to transfer the heat. Now coming to thermal conduction. If you take an iron rod and place its one end at a flame and the other end in your hand, after some time you can feel heat in your hand. This is due to the transfer of heat from the flame to your hand by thermal conduction through the iron rod. Take water in a vessel and heat it and then place our palm above the vessel. We can feel the heat. This is because the water in the vessel is heated and it becomes vapor, and this vapor carry heat and reach our palm. This is an example of convection. So coming back to our topic. So how does induction cooktop work? Is it through convection, conduction, or through radiation? Let's find out. In an induction cooktop, a coil of copper wire is placed under a cooking pot and an alternating electric current is passed through it. The resulting oscillating magnetic field wirelessly induces an electric current in the pot. This current is called eddy current. So what are eddy currents? Eddy currents are loops of electrical currents induced within a conductor by a change in magnetic field in the conductor according to Faraday's laws of induction. So this large eddy current flowing through the resistance of the pot results in resistive heating. And this heat which is produced in the cookware is transferred to the food, water, or whatever you are cooking. For almost all model of induction cooktop, cooking vessels must be made of or contain a ferrous metal such as cast iron or some stainless steels. The increased magnetic permeability of the material decreases the skin depth. Skin depth is the depth from the surface of a conductor to a point till there is electric current flow. So as the skin depth decreases, the current is concentrated near the surface of the metal, and so the electrical resistance will be further increased, resulting in Joule heating. In paramagnetic materials like aluminium, the magnetic field penetrates deeper and induced current encounters little resistance in the metal. Therefore, will produce very little heating. This is why we do not use aluminium or copper vessels on an induction cooktop. But if we place aluminium vessel on an iron plate, then it can be used since the iron plate will be heated by induction and this heat can be transferred to the aluminium vessel. Another thing that we must notice is that if the metal is too thin, heating will not be effective. For effective heating, the metal should be thicker than the skin depth. It should also have flat bottom since the magnetic field drops rapidly with distance from the surface. All metal induction tops are also available which use much higher frequencies. Induction cooking provides fast heating, improved thermal efficiency, and more consistent heating than cooking by thermal conduction. The higher the power input, the faster the cooking time. In case of induction cooker, we can see that the cooker is heated only by the pot, but for gas or other cooking methods, that is not the case. So it is very safe and efficient to use an induction cooking top than any conventional method of cooking. If you find this video informative, please click the like button, comment, share, and subscribe. See you in the next video. Thanks for watching.